Okay, so this is slow sand filters. Okay, ഇതിന്റെ ഒരു അഡ്വാൻസ്ഡ് ആയിട്ടുള്ളതാണ് റാപ്പിഡ് സാൻഡ് ഫിൽറ്റേഴ്സ്. സ്ലോ സാൻഡ് ഫിൽറ്റേഴ്സിന്റെ one of the biggest advantages is that it can remove bacteria up to 98 to 99%. So bacteria removal is very very high. The bacteria can be removed at a very high efficiency in the slow sand filters. So as you can see, this is a slow sand filters. Here the filter bed will be there. Water will be coming through here, and the water will be filtering through this under grains, and it will be collected in the distribution channel over here. It will be connected to the through the lateral drains. It will be connected to the main drains, and then to the filtration channel. Okay, sorry, next to the distribution channel. So that is slow sand filters. Okay, so even we have to do a problem on the slow sand filters that we'll discuss in the next, not next in the offline class we can study. Coming to the next portion, that is rapid sand filters. So before studying rapid sand filters, you need to have a clear picture about what is a slow sand filter. Okay, then only you can study and understand what is rapid sand filters. Okay, so slow sand filters we are having a rectangular box and another filter media in the filter media vellam pass to the lateral grains, to the main drains, to the distribution channel. So that's how it goes in the slow sand filters. Coming to the rapid sand filters. So here the structure is pretty complex compared to slow sand filters. So here one advantage is that the filtration is at a faster rate compared to slow sand filtration. Here the filtration will be at a faster rate. Okay, all the filtration will be occurring at a faster rate. But one disadvantage is that bacterial removal efficiency will be very less. Not very less, it will be around 80 to 90%. Okay, bacteria removal efficiency കുറവായിരിക്കും, പക്ഷേ rate of filtration is very high over here. So this is a structure of a rapid sand filter. So rapid sand filters nothing you can see. So this is the inlet chamber. Okay, so through here water will be coming. Okay, this is through here water will be coming, and this is the inlet chamber. Okay, so inlet chamber, and from this inlet chamber water will be draining towards the filter media. So filter media, same, top portion will be sand and bottom portion will be gravel. Okay, so ഇതുപോലെ ആയിരിക്കും, and the water will be draining towards the filter media, and the water will be drained over here. So here they have provided a central drain. കുറേ വലിയ drains provide ചെയ്തിട്ടുണ്ട്. Okay, so through these drains the filtered water will be collected. Okay, through these drains the filtered water will be collected. Okay, so see, you can see this is the construction of the rapid sand filters. Okay, it consists of a rectangular tank, so it will be like this. There will be different units like this. Okay, this will be an open rectangular tank. Okay, this it will be having an open rectangular tank, and it will be made up of either it will be made up of this portion, it will be made up of either masonry or concrete. And depth, that means the height will be around 2.5 to 3.5 meters, and area of each unit will be 10 to 80 mm square, 80 meter square. Okay, ഓരോ യൂണിറ്റിന്റെ area will be between 10 to 80 meter square. ഇവിടെ ഒരുപാട് യൂണിറ്റ്സ് ഉണ്ട്. യു ക്യാൻ സി ഡിഫറെൻറ്റ് ടൈപ്സ് ഓഫ് ഒരുപാട് യൂണിറ്റ്സ് ഉണ്ട്. ഓരോ യൂണിറ്റ്സിന്റെ ഏരിയ വിൽ ബി 10 to 80 meter square. Okay, now the filter media, അതായത് ആ ഫിൽട്ടർ ബെഡ്, ഇറ്റ് കൺസിസ്റ്റ് ഓഫ് എ സാൻഡ് ദാറ്റ് is 60 to 90 centimeter thick. അതിന്റെ എഫക്റ്റീവ് സൈസ് വിൽ ബി 0.35 to 0.55 mm, and uniformity coefficient will be around 1 to 1.7. Okay, so just like slow sand filters, നമ്മൾ അതിന് താഴെ വരുന്നത് സാൻഡിന്റെ താഴെയുള്ള ഗ്രാവൽ പാർട്ടിക്കിളിൽ ഫൈനസ്റ്റ് വിൽ ബി ഓൺ ദ ടോപ്പ് ആൻഡ് കോഴ്സസ് വിൽ ബി അറ്റ് ദ bottom. Okay, so that's the filter media, same like slow sand filters. Okay, you can see this is the composition of slow sand filters, sorry, rapid sand gravity filters. Okay, okay, so this will be the filter bed. Okay, that is the filter bed. So the gravel will be now below the sand you will be having the gravel media. It will be acting as a supporting media, and this gravel will be of height is 60 to 90 centimeter thick. That 60 to 90 centimeter thickness height ladki gravels provided in and it will be provided in some 5 or 6 layers. So that gravels will be provided in a 5 or 6 layers, and each layer will be having around 10 to 15 centimeter thick. Okay, so same like before, the coarsest will be placed at the bottom, finals will be at the top, and intermediate ആയിട്ട് വരുന്ന കുറച്ച് sands or gravels will be in the middle portions. Okay. No, another peculiarity of this rapid sand filter is that it is having a very defined under drainage system. Okay, so that means it will receive and collect water for the filtered will collect the filtered water. അതായത് they can see the water will be draining like this. Okay, so here if you see, so വെള്ളം, that water will be draining through here. Okay, draining through here, and so see water will be draining through here, and here there will be under drainage system. So the under drainage system will be collecting all the filtered water. Now another one important thing is that rapid sand filter is having backwashing. So what do you mean by backwashing? Okay, what do you mean by backwashing? Okay, so backwashing means before slow sand filters how the cleaning is occurring, we are scraping at the top layer ചളികളൊക്കെ നമ്മൾ ചിരണ്ടി കളയാ ചെയ്യുന്നത്. That means water is flowing through here. Okay, water is flowing through here. Okay, so here you can see the all the dirt particles will be deposited. Okay, so you will be scraping നമ്മൾ ചിരണ്ടി കളയും slow sand filters, but in rapid sand filters we are removing all this dirt, all the impurities through the backwashing. So what do you mean by backwashing? That means a portion of the filtered water will be uh, given for the backwashing. അതായത് നമ്മൾ one second. ഓക്കെ, അതായത് നമ്മളിപ്പോൾ എടുത്തിരിക്കുന്ന വെള്ളം, ഈ ഫിൽട്ടർ ചെയ്യുന്ന വെള്ളത്തിന്റെ ഒരു കുറച്ച് ശതമാനം വെള്ളം നമ്മൾ എന്ത് ചെയ്യും, തിരിച്ച് നമ്മൾ ഇതിലോട്ട് ഇങ്ങനെ കയറ്റിവിടും, reverse direction flow ചെയ്യിപ്പിക്കും. Okay, so the water will flow in the reverse direction and it will be going upwards and it will remove all the dirt particles. അത് ഇങ്ങനെ കളക്ട് ചെയ്തിട്ട് ഈ വെള്ളം ഇവിടെ നിന്ന് എടുത്ത് കളയും, അതായത് അടിയിലോട്ട് നമ്മൾ വെള്ളം ഫ്ലോ ചെയ്യിപ്പിക്കും. Okay, so what will happen, water will take all the impurities that is in the ഫിൽട്ടർ ബീഡ്. ഓക്കെ, ഈ ഫിൽട്ടർ ബീഡിലുള്ള എല്ലാ ഇമ്പ്യൂരിറ്റീസും വെള്ളം കളക്ട് ചെയ്തിട്ട് മുകളിലൂടെ ഫുള്ള് ചളി വെള്ളം മുകളിലോട്ട് അങ്ങ് നമ്മൾ ഡ്രെയിൻ ചെയ്ത് കളയും. ഓക്കെ, മുകളിലോട്ട് നമ്മൾ ആ ചെളിവെള്ളം ഡ്രെയിൻ ചെയ്ത് കളയും. സോ ദാറ്റ് ഇസ് ബാക്ക് വാഷിംഗ്. ദാറ്റ്സ് വൺ ഓഫ് ദ മോസ്റ്റ് ഇമ്പോർട്ടൻറ്റ് പ്രൊസീജിയർ ദാറ്റ് ഇസ് ഹാപ്പനിങ് ഇൻ ദ റാപ്പിഡ് സാൻഡ് ഫിൽറ്റേഴ്സ്. അതായത് നമ്മൾ ഫിൽറ്റർ ചെയ്ത് വെച്ച ഒരു വെള്ളത്തിന്റെ ഒരു പോർഷൻ നമ്മൾ എന്ത് ചെയ്യും, തിരിച്ച് ഫ്ലോ ചെയ്യിപ്പിക്കും, തിരിച്ച് അടിയിലോട്ട് ഇങ്ങനെ ഫ്ലോ ചെയ്യിപ്പിക്കും. സോ വാട്ട് വിൽ ഹാപ്പൻ, ദിസ് വാട്ടർ വിൽ കളക്ട്, ഇങ്ങനെ അടിയിലോട്ട് ഫ്ലോ ചെയ്യുന്ന സമയത്ത് ഇറ്റ് വിൽ ടേക്ക് ഓൾ ദ വാട്ടർ, ഇറ്റ് വിൽ ടേക്ക് ഓൾ ദ ഡർട്ട്സ് ആൻഡ് ഇറ്റ് വിൽ ഇങ്ങനെ ഓപ്പോസിറ്റ് ഇങ്ങനെ ഫ്ലോ ചെയ്തിട്ട് ഈ വെള്ളം ഇതിലോട്ട് എടുത്തിട്ട് മുകളിലോട്ട് ഡ്രെയിൻ ചെയ്ത് കളയും. ഓക്കെ, സോ ദാറ്റ് ഈസ് ബാക്ക് വാഷിംഗ്. ഓക്കെ, സോ ലെറ്റ്സ് ഇതൊക്കെ അവിടെ നിൽക്കട്ടെ. Now coming to the working of a rapid sand filters. Okay, rapid sand filters, how it is working, that is effluent from the coagulation sedimentation tank will be entering to the inlet chamber. So before the slow sand filter, they have clearly mentioned that you can only take water from the plain sedimentation tank, but in the rapid sand filters you can take the effluent or we can take the water from the coagulation sedimentation tank. Okay, coagulation sedimentation tank എന്നുള്ള വെള്ളമായിരിക്കും റാപ്പിഡ് സാൻഡ് ഫിൽറ്ററിലേക്ക് കടത്തിവിടുക. Okay, and what will happen? The water will be percolating to the sand layer, and then it passes through the gravel layer and finally collected in the under drains. Okay, now the filter water will be draining to the collection chamber or the distribution chamber. So that's what happening here. So this is a video. So this is a video of a rapids and gravity filters. So this is the filter bed. Okay, this will be the filter bed. So we are not having this lab settings and nozzles ഒന്നും നമുക്ക് ഇവിടെ ഇല്ല because this is കുറച്ചും കൂടെ advanced ആയിട്ടുള്ളതാണ്. Okay, this is that we are not seeing. Okay, instead of this lab settlings and nozzles, here we are having the under drainage system. See, this is what happening here. Okay, അതായത് okay, so this is the inlet chamber. So in the inlet chamber like വെള്ളം വിടും. Through the inlet chamber it will be entering to the filter media. Okay, okay, so now we can see at the inlet media lode നമ്മൾ വെള്ളം filter. See here water has been filtered. Okay, so water is entering to the chamber. Okay, so this is a filter bed over here. So you can see that is filter bed. Through the filter bed the filtered water will be collected over here. Okay, see filtered water, you can see the filtered water is collected through the so here you can see a portion of water. See normally this filtered water is collected over here, but you can see here a portion of filtered water is returning through the bottom layer. Sorry, bottom chamber lode നമ്മൾ കളക്ട് ചെയ്ത filter water ഒരു portion തിരിച്ചൊഴുകുന്നുണ്ട്. You can see here. See, so that is for the backwashing. That is for the cleaning of the rapids and filters. So see, a portion of water is coming back and now the backwashing is occurring. You can see the backwashing now. Okay, so before backwashing, first of all, you will drain all the water from the filter bed. Filter bed നിലവിലുള്ള വെള്ളം എല്ലാം നമ്മൾ ഒഴുക്കി കളയും. എന്നിട്ട് നമ്മൾ ഇതിനെ ഫുള്ള് കാലിയാക്കി വെക്കും. Okay, then നമ്മൾ ബോട്ടം പോർഷനിൽ സ്റ്റോർ ചെയ്ത് വെച്ചിട്ടുള്ള ആ ഒരു filtered വെള്ളത്തിന്റെ ഒരു ഭാഗം. Okay, that will be given as the backwashing. Okay, so first of all, you have drained all the water. Now see here we have stored a portion of the filtered water. Okay, all these things air scoring I will tell you. First of all, you understand what is backwashing. See, the water will be from the bottom portion, water will be flowing upwards. Okay, so you can see as the water is flowing upwards, this water is getting dirty. No, top portion water has become dirty. That means it is removing all the dirt particles that is trapped in the filter bed. See. See the top water. നമുക്ക് ചളിവെള്ളമാണ് കളക്ട് ചെയ്തിട്ടുള്ളത്. And this water will be collected and removed. Okay, that means ആ dirt water മുകളിലൂടെ നമ്മൾ റിമൂവ് ചെയ്യും. So this is called as backwashing. Okay, so നമ്മൾ this process, that means the water will be flowing from the back portions. അതായത് നമ്മൾ അടിയിൽ കൂടെ വെള്ളം മുകളിലോട്ട് കയറ്റി വിടും. So this process will continue until the water gets clearer. Okay, so initially you have seen, the water is, you can see the color of the water. So from the color of the water we can assume the dirt that is trapped in the filter bed. Okay, അപ്പൊ ഈ കലക്ക വെള്ളമൊക്കെ മൊത്തം പോയിട്ട് വെള്ളം നല്ല ക്ലിയർ ആവുന്ന വരെയും നമ്മൾ അടിയിലോട്ട് വെള്ളം കയറ്റിവിടും. Okay, so see, now the water has become clear. You can see now the water has become clear. Now you have stopped all the process. Now the backwashing is stopped. Now back to filtration. Okay, now the filtration is again the filtration will be doing. So did you understood what is this rapid sand filters and backwashing? Because backwashing is very, very important. So backwashing is one of the peculiarity of this rapid sand filters. Okay, so this is another video, that is a real video of backwashing. Okay, so this is a real rapid sand filter. This is not a 3D picture. Okay, for circular filter, this is an original filtration chamber, and here you can see the how the backwashing is occurring. Okay, so in rapid sand filters, so this is the different units of rapid sand filter. So it will be like this. There will be different units. So you can see because of the filtration, the filter media has become dirt. Okay, that filter media has become like a lot of dirt has been trapped in the filter media. Okay, ഒരുപാട് ചളികളൊക്കെ അതിന്റെ മുകളിൽ ഫോം ചെയ്തിട്ടുണ്ട്. You can see all the dirty skins. Okay, so now it's time to clean the filter media. Okay, so how is in rapid sand filter, that is through the backwashing. Okay, original video നമുക്ക് ഒരിക്കലും you cannot see that water pumping from the bottom portion. Okay, so you can see they have first drained all the waters. Now the water is draining from the bottom. Okay, വെള്ളം അടിയിലൂടെ ഇങ്ങനെ കയറ്റി വിടുന്നുണ്ട്. See, you can see ആ ചളിവെള്ളമാണ് പോയിക്കൊണ്ടിരിക്കുന്നത്. വെള്ളം ഞാൻ അടിയിലൂടെ കയറ്റി വിടുമ്പോൾ it will take all the impurities that is trapped in the filter bed. It will be taking all the impurities that will be trapped in the filter bed. Okay, അതിങ്ങനെ നമ്മൾ മുകളിലോട്ട് ഡ്രെയിൻ ചെയ്ത് കളയും. So that is backwashing. Okay, so this is a real picture of backwashing. Okay, so now you can see the water is getting clear. See, now you can see because for after a certain period the water will get clear. Okay, initial ആ വാട്ടറിന്റെ കളറല്ല വെള്ളത്തിന്റെ കളർ മാറി തുടങ്ങി. Okay, so that means it has become clear now. See, now the water is very clear, which means that the filter, all the filter bed is clean now. ഇപ്പൊ നമ്മൾ അടിയിലൂടെ വെള്ളം കയറ്റി വിടുമ്പോൾ it will be taking all the dirts, and now it is very clean. The water is very clean. Okay. You can see the clear water that is flowing. Okay, so that is rapids and gravity filters. Okay, so that's about the rapids and gravity filters. So I think remaining everything we can study using PPT. The basic thing നമ്മൾ മനസ്സിലാക്കി കഴിഞ്ഞു കഴിഞ്ഞാൽ. Okay, so now you have understood the all the working and how the rapids and filters are working. Now let's go to the features of rapids and filters. First one is this is used for the large town. Okay, that means when it is used for the large sized particles. That is for a big town when you have to uh, purify a large amount of water, and the water is containing of large amount of pollutants, you can go for rapids and filters. And here the rate of filter is very high. That means that is around 3000 to 6000 liters per hour per meter square. If you're taking into meters, it will be 3 to 6 meter cube per hour per meter square. So this much of amount of filtration is doing here. Okay, now another important thing is that here water from the coagulation sedimentation tank is used. Okay, that means the coagulation sedimentation tank in the വരുന്ന വെള്ളം, it will be having a lot of flocks, lot of small amount of flocks will be there. So because of that reason, it cannot be used for the slow sand filters, but for the rapid sand filters you can take water from the coagulation sedimentation tank. Okay, now after the once the filtered water, okay, the filtered water, it will be treated with the disinfectants. Okay, even after the rapid sand filters filtration കഴിഞ്ഞ് കഴിഞ്ഞാൽ the filtered water, it will be treated with the disinfectants. That means if there is any kind of bacteria is present or any kind of microbial action is present, it will be killed. One of the disadvantages of this rapid sand filters is that it is very less efficient in removing bacteria and turbidity. Okay, turbidity bacteria remove ചെയ്യാൻ കുറച്ച് less efficient ആണ്, but the rate of filtration is very high. As far as it is concerned, you need to filter large amount of water at a faster rate, and it removes bacteria up to 80 to 90 percentage. Okay, and remaining bacteria is removed by disinfection methods. Okay, so through rapids and filters 80 to 90 percentage of bacteria can be removed, and remaining bacteria can be removed using disinfectants. Like you can use chlorine, you can use ozone, or you can use different types of disinfectants like that. Turbidity can be removed only up to 35 to 40 mg per liters. Okay, so we have seen the construction. Means basically it will be having an enclosure tank, it will be having a filter media which is consist of a sand, a gravel portion, and also an under drainage system. Okay, now the under drainage system, it will be having this manifold and lateral drains. That means it will be like this. Okay, the bottom under drainage systems, it will be having a manifold and lateral drains. So manifold means it is a 40 centimeter diameter main drain which is running through the center. അതായത് സെന്ററിലൂടെ you can see a pipe will be going. Okay, you can see a pipe is going which is having a diameter approximately 40 centimeter. Okay, so that is called as manifold. Through the center a pipe will be going which is having a diameter of 40 centimeter. So that pipe is called as manifold, and to the manifold you can see different types of lateral drains are attached. You can see ഒരു 10 centimeter diameter ഉള്ള you can both these portions lateral drains. Okay, 10 centimeter diameter ഉള്ള pipes will be attached. You can see here. See, this is 10 centimeter diameter pipes, and this will be placed at a distance of 10 to 30 centimeter apart. That means distance between these lateral drains is 10 to 30 centimeters. Okay, so this is lateral drains. Now, another important thing is that this lateral drains will be having perforated pipes and strainer system. Okay, ഈ lateral strain, അതായത് ഈ lateral pipe there will be perforated pipe systems and pipe strainer system. Okay, what do you mean by perforated pipes and pipe strainer system? Okay, so perforated pipe system means the lateral drains with the holes at the bottom. That means 6 to 30 mm diameter holes at the 30 mm with vertical, and it will be spacing at a spacing of these holes will be 7.5 to 20 centimeter. That means this lateral drains. Okay, as you see in this figure, ഈ lateral drains in the bottom portion holes ഉണ്ടാവും. Okay, I don't have that figure right. Okay, it's okay. Okay, ഈ lateral drains in the bottom portion there will be a holes. Okay, there will be a holes which is having a diameter of 6 to 13 mm. Okay, which will be having a diameter of 6 to 13 mm, and it will be having a 30 mm vertical height. കുറച്ച് 30 mm vertical height ഉള്ള ഒരു 3 mm 3 mm height ഉള്ള ഒരു 6 to 13 mm diameter ഉള്ള holes will be in the holes will be given at the bottom portion of this lateral drains. Okay, okay, now the spacing of these holes will be 7.5 to 20 centimeter. Okay, this holes will be spaced at a 7.5 to 20 centimeter distance. Now, pipes and pipe strainer systems. Okay, the lateral drains with a strainer pipe. That means this pipe strainer system. It will be this lateral drains will be having a pipe with the perforated caps. You can see the caps are provided here. Okay, the caps are provided here. Okay, with strainer pipe or cap provided now. Okay, and this strainer pipe will be at a 15 centimeter apart the lateral pipe. Okay, ഈ lateral pipe ഇതന്നെ ഇതിനോട് ചേർന്ന് തന്നെ ഇതാ you can see as an extension of this. Okay, ഇതിനോട് ചേർന്ന് തന്നെ നമ്മൾ ഒന്ന് നീട്ടി കൊടുക്കും, പൈപ്പ് കുറച്ച് നീട്ടി കൊടുത്തിട്ട് ക്യാപ്പ് കൊടുക്കും. So that is strainer system. Okay, that is called as strainer system. Okay, so rapids and gravity filter the bottom portion this is earlier in the video I have shown you that is a slab setting. So that is a very advanced rapids and filters. Okay, so for the syllabus for syllabus we have to study this. That means the bottom portion consists of a manifolds and main drains. Sorry, manifolds and lateral drains. So this is the manifolds and this is the lateral drains. This lateral drains are having perforated pipes and strainer system. That means the pipe with the perforated caps. Okay, perforated caps holes like caps. Now another important thing is that wash water trough. Wash water trough, that is mainly to collect the dirty wash water that comes out of the filter after cleaning it. Okay, so it can be square, it can be V-shaped, or it can be any semicircular in section. It will be made up of steel or concrete or whatever it is. Okay, so in the earlier we have seen in the video we have seen that video of backwashing. Okay, so backwashing, after backwashing in the all the water will be collected drained from the top. Okay, so അങ്ങനെ ചളിവെള്ളം ഒഴുക്കി കളയാൻ വേണ്ടിയിട്ട് top portion you are providing a wash water trough. So this is that wash water trough. Okay, wash water trough, that means to drain off all the dirt water during the backwashing. Okay, to drain off all the dirty water during the backwashing. Okay, so that is wash water trough. So there is trough. Okay, so water will be drained through this trough. ഇതിലോട്ട് വെള്ളം കളക്ട് ചെയ്യും, ചളിവെള്ളം ഇതിലോട്ട് കളക്ട് ചെയ്യാൻ വേണ്ടിയിട്ട്. ഓക്കെ, ഇറ്റ് ക്യാൻ ബി ഓഫ് ഡിഫറെൻറ്റ് ഷേപ്സ്. ഓക്കെ, നൗ ദ ഡിസ്ചാർജ് ടു ദിസ് വാട്ടർ വാഷ് ഡ്രം is computed by an equation that is 1.36 by all raised to 3 by 2. Okay, b is the width and y is the depth. Okay, so this thing we can study while we are doing the problem. Another important thing is that air compressor. You might have seen the air compressor. Okay, that means for agitating the filter during the back washing. Okay, so that means bottom motion you are providing an air filter now. Okay, that is mainly for agitating the filter during the back washing. Okay, so it should be able to provide a compressed air at the high rate. That means നമ്മൾ അടിയിലോട്ട് you will be providing a compressed air at a very high rate. That is mainly to agitate the filter media. അതായത് I think in that video I have shown you that backwashing. That water is collected, water is going backwards, backward direction la. Can you see the video? So see, so there will be at the bottom portion they will be providing an air scoring wall. Okay, will be providing an air scoring wall. That means to allow a compressed air to pass through. Okay, so this is what I can see from this figure. See, ഒരു compressed air ഇതിലൂടെ flow ചെയ്യുന്നുണ്ട്. That means a compressed air is flowing into the filter media. Okay, so the compressed air will be flowing into the filter media. ഓക്കെ, ഇത് എന്തിനാന്ന് വെച്ചാൽ ടു ഒന്ന് അജിറ്റേറ്റ് ചെയ്യാൻ വേണ്ടി. ദാറ്റ് മീൻസ് ടു ഫിൽറ്റർ മീഡിയം ഒന്ന് ഇളക്കി കൊടുക്കാൻ വേണ്ടിയിട്ട്. അതിൻ്റെ ഫിൽറ്റർ മീഡിയൻ്റെ ഇടയിൽ എന്തെങ്കിലും ഡേർട്ട് ഒക്കെ ഉണ്ടെങ്കിൽ അതൊന്ന് ഇളക്കി കൊടുക്കാൻ വേണ്ടിയിട്ടാണ്. ഓക്കെ, സോ ദാറ്റ് ദ ഡേർട്ട് വിൽ ബി വെരി വെൽ റിമൂവ്ഡ് ഫ്രം ദിസ് ഫിൽറ്റർ മീഡിയം. Okay, that means if you pass this compressed air pass ചെയ്യുമ്പോൾ that filter medium ഒന്ന് agitate ആവും. Through this agitation, if there is any dirt particle which is trapped between the filter pads, it will be flowing with the water upwards. Okay, വെള്ളത്തിൻ്റെ ഒപ്പം മുകളിലേക്കൊന്ന് ഫ്ലോ ചെയ്യാൻ വേണ്ടിയിട്ട്. So that is air compressor. Okay, so that means that's an air compressor that is provided. Okay, next one is a rate control. That is commonly a Venturi controller. That means a Venturi meter will be provided to provide a uniform rate of filtration. Okay, that means ഒരു uniform rate of filtration കൊടുക്കാൻ വേണ്ടി ഒരു Venturi meter will be provided. Okay, so that's next is working of rapid sand filters that we have discussed. Okay, cleaning, this also we have discussed. Back washing. Okay, okay, I think almost rapid sand filters also we have covered now. So this is very important. From this module, this is the question that will be asked for the university: slow sand filters and rapid sand filters. Okay, so you have to study it. I think we can buy. It's time to wind up today's class. You can post your name to mark the attendance now.